Hi, I'm Brayden, and I'm going to present to you my neuroplasticity project and how the brain rewires itself through neuroplasticity. So here are my four audience members. All right. So, have you ever walked into a room and instantly forgotten why, or maybe surprised yourself by picking up a new skill faster than expected? Those moments aren't just quirks, they're signs that your brain is constantly adapting. This everyday process is called neuroplasticity. No matter your major, career goal, or hobbies, neuroplasticity affects you. It shapes how we learn new materials, adapt to stressful situations, and even recover from injuries. In other words, it's your brain's built in way to grow and survive. To better understand how this works, I've been reviewing peer-reviewed research articles from neuroscience journals. What I've found is that neuroplasticity reveals itself in three key ways: in brain cell activity, in differences between male and female brains, and in how we design artificial intelligence. Let's start with what's happening at the microscopic level. Inside our brains, there are proteins like BDNF and ARC that help neurons connect and rewire. These proteins work like a construction crew, reshaping pathways to help us learn and recover. According to Giovanni Ciroli, writing in a 2025 article in Frontiers in Molecular Neuroscience, these proteins are essential for remodeling brain cells and learning and healing. But not all brains respond the same way. In a 2024 article from Scientific Reports, research E.D. Kirby and colleagues used MRI scans to study motor learning. They found clear differences in how male and female brains adapted. When the data was combined, those differences disappeared. This shows why research and rehab strategies need to account for sex-specific changes, because ignoring them might cause us to miss what's really going on. Now let's take a step outside the human brain and into machines. In a 2024 article in a PLOS 1, Vandenberg and his research team introduced Recollect, an artificial intelligence model that mimics how the brain learns and forgets. It's based on real neuroscience principles and is adapted or designed to adapt over time, just like us. This kind of AI could change the way we build smarter, more human-like technology. So what does all this mean for us? Neuroplasticity shows up in three powerful ways: through microscopic activity in brain cells, in differences between sexes, and in how we're programming machines to think and learn. The next time you struggle to memorize something or bounce back from a tough moment, remember your brain is not stuck. It's flexible. It's constantly changing, and that's what makes it so powerful and unique. So yeah, that is my presentation, and here are my audience members again.